This conference will now be recorded.
This was our okay. So this was our day initial demo session agenda. So we discussed these points. What is performance testing? Why performance testing? LoadRunner architecture, sample, record and replay, and and course content and all that stuff. Yesterday we discussed different types of performance testing, and in these different types of performance testing, we discussed about load test, stress test, endurance soak or duration test, scalability test, volume test. Okay, so we didn't discuss this. So today we will be discussing this failover test as well. I'll also explain you what is smoke test as well. So before understanding what is failover test, so I would like to uh, discuss these concepts first. So from performance tester point of view, what is the importance of software architecture? Okay, so from performance tester point of view, what is the importance of software architecture? For example, see, we have this username and password text box. Let's say this is a login page of some XYZ application. Okay, now you have this username, password, and then you have submit button. Now, user enters username and password, and then clicks on submit button. Okay, user logged in successfully. Okay, user logged in successfully. Now, let's assume it is taking like 3 minutes. Let's assume it is taking like 100 seconds or 150 seconds, okay, to log in. Is it okay for you? See, user is able to log in successfully, but it is taking, let's say, 100 seconds. Okay, you enter username, you enter password, you click on submit button, but the page keeps on loading. But it takes 100 seconds and it will display the home page. Okay, now is generally from performance perspective, is 100 seconds a good response time? Do you think that 100 seconds is okay for us to load
No.
the page? No, right? So why it is taking 100 seconds? How do we know? It is taking 100%, but why? Why it is taking 100%? Sorry, 100 seconds. That's where we need the software architecture will come into picture, and we need to understand the architecture. Okay, we need to know the importance of it. So here I mentioned some points. What if the login process is slow? Reason could be an issue with the application. Okay, so when I say reason could be issue with the application, okay, uh, in order to know what is the issue with the respect to the application, we need to know the back-end architecture. For example, you enter username, password, you click on submit button. What is happening when you click on submit button is important for us. So you click on submit button. What is happening in the back-end? Okay, in the UI you can see submit button, but in the back-end, what is happening? That is important. Okay, now when you click on submit button, when you click on submit button, in the back end, this data might go to database, and then it will get the username and password. It will validate the data, and then it will allow you to log in successfully if both the username and password are correct. Okay, possible. So from performance tester point of view, we need to know what is exactly happening in the back end. Okay, so whatever the issues because of which the login process is slow here, it is called bottleneck. See, basically we call it as an issue. Okay, basically we call it as an issue, but in performance testing terminology we call it as bottleneck. Okay, so see, there is a application issue, there is a database issue. Okay, there is a web service issue. We use the term issue everywhere, but in general, the ideal term that we need to use is bottleneck. Okay, there is a bottleneck here, there is a bottleneck in the database, there's a bottleneck in the UI, the application is not responding, looks like there is some bottleneck. Okay, so to identify the issue or to identify the bottleneck, we need to understand the architecture of the software application. Okay, so when you click on this button in this example, when you click on this button, what is happening in the backend? That is very, very important. Okay, now what will be there in the backend? In the backend, there will be something called servers. Okay, there will be something called servers. So what is a server? Okay, what is a server? So a server is something which will understand the request sent by you, and it will process the request, and it will send the response back. See, you click a button here, you click a button here, and now the data is going, the request is going to server. Now the server will have to understand it and then process it, and then send the response back so that you can see the home page here, right? You can see the home page, successful home page. Okay, so any software program, okay, which is actually capable of doing these three, which is actually capable of doing these three, then which is capable of doing these three, these are called a servers. Okay, but in general, a software can a software run on its own? Generally I have a software. Okay, can I run it on can I run it directly without any hardware support? So we need some hardware support also, right? So basically combination of both software program and hardware together, okay, which can uh, understand your request, process your request, and then send the response back is called a server. So here in this image, this is a server. It is accepting request from the client, okay, and then it will understand what the request is, it will process it, and then it will send the response back, and then whatever the response it is sending, it will be displayed, it will be converted into html, the html pages, and it will get displayed here properly, like what we see on the UI. Okay, so any questions with respect to server? Did you guys understand? So basically every application, whatever we are accessing, we are clicking either link or we are clicking a button. Okay, we are sending some data to server, and server is understanding it, processing it, and sending the response back. Okay, and then all these three are done by the server. Now how this, when you send a request, how the server is understanding on, okay, on how it is understanding, I'll tell you in some time now. Okay, on what basis, when you send a request, how the server will understand, I'll tell you in some time. Okay, now any questions with respect to server? You understood these things, right? So it's a simple concept only. Okay, so every, in our entire course, I mean, very frequently I might use this term server, server, server. Okay, you might hear this term in general also, like server crashed. You might go to a bank and they will say server crashed. You might go to a train ticket system and they will say server crash. So in that, so what do you mean by that? The backend system which has to respond, it is down. It is not responding. That's the reason they will say crashed or something like that. Okay, so the server is very, very important. The entire data it will only process. How many requests it might go? Okay, like from hundreds, thousands of requests are going. Every request will be processed here depending on its capacity. Okay, we'll discuss. Now, let me go to the next slide. So if you want to understand or analyze the exact performance issue, you need to understand the architecture. Okay, so the most common architecture is this. Okay, so you have a client, that means the UI, where you click a link or you click a button. When you click a link or click a button, the immediate request will go to, first it will go to web server. Okay, so when you click a link or when you click a button, HTTP or HTTPS request, HTTPS request will go to HTTP or HTTPS request will go to web server. Okay, what is web server? What is web server? Basically, where the application is hosted. Okay, you might have heard these terms. Some people saying, "Hey, I have developed this application. We are going to host it in a server." Okay, what is like what is, or it can say like it will host websites. Okay, it can host websites. I have developed a website. I'm going to host it in the server, right? So what is a website? So website is nothing but a collection of web pages. So you have a website, you click a link, it will go to other page. You click another link, it will go to other page. It's a collection of web pages. Okay. So whenever we click any link or any button on the UI, first the request will go to web server. Okay. And the examples of web server are we have Tomcat, we have Microsoft IAS, etc. Okay, generally I'm just saying generally for all Java projects and all, mostly they use Tomcat. For .NET projects and all, they might use IAS because IAS is from Microsoft. Okay, so these are the two most frequently used web servers. Okay, so whenever you click any link or you click any button, the first request will go to web server. That's where the website is hosted. The website is nothing but collection of web pages. Okay, now, oh sorry, uh, now this web server, what it will do, it will simply forward that request to application server. It will simply forward that request to application server. Like if it is a Java application, like a servlets, Java servlets pages, so requests and all those things. So um, uh, web server will simply forward that request to application server. Now application server is the most important one. Okay, and the entire business logic, the entire code the developer has written, everything will be stored in this application server. Okay, so developer will develop so many logics, right? Then only the application will work. So the entire business logics will be resided in this particular application server. Okay, so you have a project for which you are developing for which you are working as a performance tester. That application code and the entire business logic will be resided in this particular application server. Okay, so there are different application servers like WebSphere, WebLogic, etc. Okay, so now if required, if required, this application server will further send one more request to database server. So database server is all about storing the application data. It's all about storing application data. For example, if it's a bank, so will have bank will have to store some data like customers data, loans data, credit cards data, transfer amounts data, check data, whatever it is. If it's a college application, they have to store information related to students, faculty, administration team, transport team, security team, everything. Okay, so database server is where our application, entire application data will be stored. Okay, what are the examples of database server? Can anyone tell? Because you know most, I think most of you have heard like one or two at least for sure. Anyone can tell one or two database server names?
Oracle
Oracle,
SQL Server.
Yeah, correct. So you have Oracle, SQL Server. You nowadays you have this NoSQL like MongoDB, so on, anything like okay. So so I repeat, when you click a link or when you perform any action on the UI, the request will go to web server, which request the HTTP HTTPS request. The web server, which can be either Tomcat or IIS, will just forward that request to application server. The application server uh, is one of the important server here, in which the entire business logic will be stored or resided. Okay, and then it, if required, it will forward that request to database server to fetch some data or to validate some data or whatever it is. So database server will have all the data related to the application. That's the reason this is called as data layer. This is called as business layer. This is called as presentation layer kind of thing. Okay, so this is a data layer where the data is managed. This is a business layer where the entire business logic will be stored. This is a presentation layer because when when we get the response back like in this direction, so it will also assist. This web server will also assist in formatting the HTML data and all that stuff. Okay, so presentation layer, business layer, data layer. Now out of these three, now let's say I am sending some 5,000 requests. Like let's say 5,000 people are clicking a button. When 5,000 people are clicking a button, 5,000 requests will go to web server. Okay, and it will forward to application server and all that stuff. Now out of these three, can you tell me where where most of the performance issues might come up? In which layer you might see most of the performance issues?
Database.
App server.
App server.
Database server.
It's like I say both. So you might see most of the issues in application server and database server. Okay, like some 40% or something like 45%. So just 5 to 10% or 5 to 20% of the issues you might see on the front end, like the browser side. Okay, like you might see some browser slowness and all that stuff, but majority of the performance issues will come from database and application server both. Okay, anything. So these two are important. Now here, this application server is taking all the requests from web server. Whatever web server is getting, everything is forwarded to application server, correct? Now, will this application server be good enough to withstand the load? Will it be able to process all the requests that it is receiving? See, it depends on the amount of requests re- received by this application server, and it also depends on the configuration of this application server. So if the configuration is good, let's say for example like 64 GB RAM, okay, octa core processor, something like that, then it's a probably a good configuration. It can process more requests. Okay, now we all know that we all know that applications, now whatever the applications, the real-time applications, they might be getting huge data. The request might be flooding in like anything. No, even though this application server has some good configuration, so there might be chance that, not there might be, definitely there will be some additional application servers instances. We call it as instances. Okay, so here the project architect might add few more application servers here, because if they think that, let's say this server is receiving 5,000 requests, let's assume, if they think that this server cannot handle 5,000 requests, what they will do, they will add another instance or node. You can call node or instance. Now when we have multiple application server instances, the load will be distributed. Okay, like you are like we are sending 5,000, so around 50% of the load will go to this and 50% of the load will go to this. Who will distribute the load? Can anyone tell who will distribute the load? If it is getting 5,000 requests, let's say 2,500 should go here and 2,500 should go here. Who will take care of it? How do
Load
Load
balancer.
balancer.
load balancer will
Load balancer.
take care of it? So basically load balancer is also a kind of software where it runs on some algorithms. Which algorithm will be used will be decided by project architect based on the requirement. There are few algorithms which we will discuss going forward. Just see, in interview they will ask you about what is your project architecture. um, what was the web server they used, what was the application server they used, what is the database server they used, what kind of load balancer algorithm they used. So you have to tell, okay, our project had some weighted round robin algorithm. So they might ask what is weighted round robin algorithm. You can tell like how it works. We need not go into details and explain the whole algorithm. It's not like that. Basically for performance testers they will just ask how does weighted round robin algorithm works. Okay, so because they want us to have a clear idea about the architecture, even though we are not involved in setting up this architecture, but we need to have the understanding and idea of the architecture. Okay, now when you add additional servers like this, we call it as scale out. When we add additional servers, then it's called scale out. In some projects, let's say they will not have bandwidth, or they will not have enough budget to uh, get a new machine. Okay, get a new machine altogether. In that case, they will upgrade the configuration. Let's say it has 32 GB till now. Now let's say they are upgrading to 64 GB and some octa-core processor and all that stuff. So when they upgrade the existing server, then it is called scale up. Okay, scale out, scale up. Okay, so when we add additional servers, then it is called scale out. When we upgrade the existing server, then it is called scale up. So before attending any interview, just remember these terms: web server, app server, database server, scale out, scale up. Okay, load balancer, its algorithms. So these are important. Now understand this architecture. Try to understand and remember this architecture. I'll tell you in relation with the failover testing in some time from now. Okay, let's go to the next slide. Here we are going to discuss about protocol. It's pretty, I mean, small topic. So this is a client machine where you click a link or click a button and then the request will go to server. Now, I said server is something which will understand your request, correct? A few minutes ago, I I was like, I explained like server is something which will first understand your request and then process it and then send the response. So the first point is, how is it understanding whatever the data that is being sent, how this server is understanding based on protocol, based on protocol. In general, protocol is nothing but some set of rules. Some set of rules. If you go by dictionary definition, it is nothing but set of rules. So what kind of data is being sent from client to server? What kind of communication is being happening here? Based on that, the protocol will be selected by the architect, the project architect. For example, if the request is all about a web application HTTPS, then you might have a protocol called HTTP or HTTPS protocol. If the data is all about sending or transferring files from this machine to this machine, we are sending files, then we will use file transfer protocol. If the data exchange or communication is all about transferring emails, then it's like SMTP, simple mail transfer protocol. So there are few protocols. Okay, I just noted a few, but it all depends on what type of data is being sent from client to server. Based on that, the protocol will be decided by the architect. Okay, so as I said, like for these two, for HTTP or HTTPS, we in our LoadRunner tool we have one protocol called web web HTTP HTML, something like that. Okay, which we selected a couple of days ago. Okay, now any questions before I move to failover testing? So you understood these concepts, right? What the importance of software architecture, what is the server all about, the entire architecture, the protocol. Okay, now just think about this diagram where we have multiple application servers, Okay, now let's try to understand failover test. So this we didn't discuss yesterday. So I'll tell you how a performance tester will actually execute this. Okay, I'll tell you directly how to execute a performance test, a failover test. So to execute a failover test, you need to coordinate with development or admin teams who have access to bring down or bring up the server. Okay, for example, so here, let's say this is application server 1, let's say server 1, let's say server 2. Okay, this is server 1, this is server 2. Now, let's say this is client from where the request is, all the requests are being triggered, let's say. Okay, in between, let's say we have something called load balancer. Okay, so this is load balancer. Now, while doing the failover test, you will have, I mean, you have this setup basically in your project, definitely. Let's say tomorrow morning, you want tomorrow morning 9 o'clock. Okay, let's say 9 o'clock. Okay, so let me write here. So let's say you want to run a load test first. Okay, so 9 a.m. 9 a.m. you want to start a test tomorrow. So today itself, you have to send an email. You have to send an email to application team or the admin team who have access to bring down or bring up the servers and tell them that we are going to run a failover test tomorrow and we need your support. So because performance testers will might not have access to bring down the servers. Okay, so 9 a.m. you start the test. Okay, 9 a.m. you start the test and 9 a.m. okay, you start the test and all the requests will be triggered. Now you can just assume this as load generator also if you want. Okay, now all the requests will be sent. Now load balancer will use some algorithm. Okay, it can use any algorithm depending on the project and it will distribute the load. Let's say it is distributing the load like this. Whatever it is getting, it is actually distributing it like this. Now 9 a.m. to 9:15 a.m. Okay, 9 a.m. to 9:15 a.m. continue this process. Now during this time period, during this 15 minutes time period, you analyze you analyze how the server 1 is behaving and how the server 2 is behaving. Okay, so when I say how it is behaving, so you monitor. You can use any APM tools like AppDynamics or Dynatrace and go and check the performance of the server 1 and server 2. How many requests are being received by server 1? How many requests are being received by server 2? How many are being processed by server 1 and server 2? How much time it is taking on an average to process? Are there any errors? Okay, all these things you can monitor using APM tools. Continue this process till 9:15. How much time it is taking to respond? Okay, continue this till 9:15. 9:15, 9:15, you ask developer to bring down one server. Okay, ask the developer to bring down one server. So developer, let's say we ask developer to bring down server 2. So this should be down. Now when this is down, the load balancer have the capability to know that one of the server is down, and what it will do is it will automatically redirect all the upcoming requests to server 1 only. It will not send it to server 2. It will not send to server 2. It will only send to server 1. Why? Because this load balancer knows that server 2 is currently down. Okay, how does it know? It has that capability because it is linked to that server. Okay, how much, I mean, within how many minutes it will come to know? Like once this server is down, this load balancer will come to know in like few seconds, like 4 seconds, 5 seconds, 6 seconds. It will understand that this is not accepting requests. Immediately, it will route or redirect all the requests to server 1. Now, what you have to do is from 9:15 to 9:30, from 9:15 to 9:30, you monitor, sorry, you monitor server 1. So because server 2 is down, right? Server 2 is down. So all the requests are going to server 1. Now monitor this server and see whether this server is able to withstand the request or the load that it is getting, whether the server alone is able to manage all the requests, and if it is able to manage, how much time it is taking to process each request. Is there any performance issue? Okay, so let's say when two servers are managing the request, let's say on an average it is taking 1.5 seconds per request. Now because this server alone is handling, it is handling double the load, there might be some performance issues, like it can take more time than 1.5 seconds. So how much more time it is taking? Is it 2 seconds, 3 seconds, 5 seconds, or is it, or or the server alone cannot handle and it got crashed? You have to monitor all this stuff. Okay, now after making note of all the important points during that time period, then ask the developer to bring the server to at 9:30, let's say 9:30 or 9:40, whatever it is. 9:30, ask developer to bring bring server to back to normal. So what developer will do? Let's say after 9:30 or 9:40, developer will again bring this up. The developer will restart or start this server. Now again, the load balancer has the capability to know that server 2 is again up and running, and immediately it will again start sending, distributing the load like this: one here, one here, one here, one here, like that. Now again monitor whether uh, these two servers are managing the load, how much time it is taking to process. Okay, were there any errors? Were there any critical performance issues? What is what is the CPU utilization? What is the memory utilization? Okay, of these servers. You need to monitor all these things in the backend. Okay, so why are we doing this? Why are we calling it as failover test? So in real time also, there is a chance that in multiple server instances, some of the instances might go down due to unexpected reasons. So in those cases, whether the remaining servers are able to handle the load or not is what we are monitoring. Okay, that's the reason it is called failover test. So nowadays it is more popular, and and it is not something we have to do in every project. If client is asking us to do, then only we will do this type of test, otherwise not required. Okay, any questions? Did you guys understand failover testing? And then you can I mean, after the server 2 is up and running, you can just monitor for another 15-20 minutes and all, you can stop the test. Okay, any questions? So
So why this called failover?
failover in sense, like that's what I said. uh, so if one of the server is down, do you have any backup, a failover machine, a backup machine? Okay, which will take care of the requests. Okay, managing all the requests. So one server is failed, it is not responding, then the other one should take care of it, take care of all the requests, right? So in real time that can happen. So to simulate that in the testing environment, we are intentionally failing over this. We are intentionally failing this server by asking the developer to bring it down. So when I say bring it down, we're intentionally failing that server. Okay, assuming that it can happen in real time. Okay, and then when it
Yes.
fails, whether now we are monitoring whether the other server is able to handle the load or not. Okay, because it is very important. If this server is failed, this server should be able to handle. Because this is failed and this is alone, and if it is not able to handle the load, this will also crash. Then the entire project application will go down.
Yes.
So so no, in real-time projects we have multiple server instances. Like if you ask me, sir, how many instances will be there in the project? It depends on project to project. I have supported projects which had 3 instances, which had 9 instances, which had 27 instances also. Okay, it depends. So So there can be multiple instances. Now, as a failover test, you can bring down one server and monitor for 10 minutes, bring down another one, monitor for another 10 minutes, bring down everything except one, monitor for 5 minutes, like that. You can do some trial and error basis based on the input provided by your application team. So you can ask your developer. So we are trying to do a failover test. So uh, do you want us to provide any approach or anything? If they want if they want us to follow some approach, you can follow. Like they want us to bring down three server instances and manage with other one or two, like depending on the overall number of instances you have. Okay, we can design an approach and follow that approach for 1 hour or 2 hours failover test. So there is no time limit like 1 hour or something like that. So you can monitor for 15 minutes, 20 minutes, like that. And you can bring down other server. You can add another server, bring down three servers, add another server. Anything you can do. Okay.
Okay.
So that is failover testing. Um, then we have smoke test. See, basically these are major types of performance testing. We have smoke test. Smoke test is a simple 5 to 10 minutes test that we run before every test. Now, let's say tomorrow morning 9 o'clock, I have to run a load test for 1 hour. So I might run a smoke test for 5 to 10 minutes today evening, or late evening, or tomorrow early morning, like 7 o'clock or something. Why? Because I want to make sure before I run the load test, I want to make sure whether my scripts are working fine, whether the application is working as expected, whether the requests are going to server properly. Okay, everything like whatever the scripts I developed, I created a scenario. Is it working as expected? So application is responding, everything. So if this smoke test, let's say to 9 a.m. you have a load test. Okay, let's say 7 a.m. you want to run a smoke test for 5 to 10 minutes, you can run. And then if smoke test is a failure, okay, then obviously you cannot run load test, any test in fact. So the smoke test is something which we run just for 5 to 10 minutes before any of these tests, just to make sure that our scripts are updated, currently running fine without any issues, and the application is also good. It is also responding well, no issues found, something like that. Okay, any questions? Just 5 to 10 minutes, and you might ask with how many users I have to run. You can run with minimum number of users, like 5 to 10 max. 5 to 10 max users, like 10 to 15 minutes max smoke test, max 10 to 15 minutes. Don't run for 1 hour, 2 hours, like that. Okay, so let's say load test is configured to run with 1,000 users. That doesn't mean that you need to run smoke test with 1,000 users. Okay, you can just run with 5 to 10 users for 10 minutes or so, because we are making sure that the application is working fine, our scripts are working fine, everything is good. Then after 1 hour, you can just trigger the load test with 1,000 users. Okay, any questions? Okay, so um, in next session, we will be discussing some important concepts, like before you, whenever you are assigned to any performance testing project, where exactly you have to start your work. So what should I do? Okay, my manager came to me and said, hey, can you do a performance testing for this application? You are the owner for this application from now on. Every 2 months or every 3 months or every 1 month, you need to run the performance test. You are the owner for these applications. Now what you have to do? Okay, if it's an existing application, what you have to do? If it's a new application, what you have to do? Where should you start your work assignment? Okay, so what are the details that you need to gather from the application team before you exactly start working your project? We will discuss those concepts, and also we will understand Okay, we'll also understand where the client is getting these numbers, from where the client is getting these numbers. Okay, the client is asking us to run with 500 users. Okay, but from where the client is giving this number to us, we'll try to understand different scenarios. Okay, so that will be our tomorrow's session, and it will be very interesting topic as well. And also uh, definite interview question from tomorrow's session. 100, I can tell you 110% you will get an interview question from that concept. Okay, I'll tell you what are those questions. I have some interview question and answers document prepared. Okay, so I prepared these different question and answers. Uh, so basically, uh, so it contains so many questions and answers, and some follow-up questions. Okay, like you will answer a question and you might get a follow-up question. So what should you answer for that follow-up question? All those things I have like created a document. I'll share this document with you guys as well. So we'll from tomorrow's concept we'll see what are the different interview questions we might get, and from tomorrow's after tomorrow's I mean from tomorrow's session, once the core concept is completed, I'll tell you what are the different interview questions you might get as well. Okay, any questions? Okay, so I'm stopping the session here. If you have any further questions, right? Oh, the session didn't record or what? I'm not sure.